Whenever we say we have a parallelogram, we're talking about a quadrilateral with two pairs of opposite sides that are parallel. That's the definition of a parallelogram. Now we also get some properties that go along with it. And so besides the two pairs of opposite sides parallel, we have that both pairs of opposite sides are congruent. We have that both pairs of opposite angles are congruent, so these two and these two. Consecutive angles are supplementary, meaning angles next to each other that share a side will always be supplementary, and this comes from same side interior angles. And last, diagonals bisect each other. So we have five things we're talking about. Two about sides, opposite sides parallel and congruent. Two about angles, opposite angles congruent and consecutive angles supplementary. And last, diagonals bisect each other, meaning they form midpoints for one another. So we're going to use those properties to help us solve values. Now eventually we get to going through and proving that a shape is a parallelogram. To do that, you have the five reasons I have listed to the right, and some of them are the same. Opposite sides parallel, opposite sides congruent, opposite angles congruent, and diagonals bisect each other. What's missing is consecutive angles are supplementary. And that's because that doesn't necessarily guarantee that it's a parallelogram. You would actually have to show all four angles work. And the fact that opposite angles congruent would be a little bit easier way. And then one pair of opposite sides congruent and parallel would be then another way to prove it is a parallelogram, which we'll look at in a minute. So we're going to take these properties and start to solve for values. So I have in my diagram here, xy is 15. Wx is 22, Zx is 52, and Wt is 23. So let's get everything labeled. So we need to go through and find some sides. ZW is first. ZW is this side. Opposite sides are congruent, so that is 15. ZY. ZY is the bottom side, opposite sides are congruent, it's opposite to the 22, so 22. TX is the distance from that center I have to here. Now I know the whole length is 52, since the diagonals bisect each other, this would be half of it, so 26, because it's 26, 26. And last, WY, which is the other full diagonal, if part of it's 23, they bisect each other, that's 23. I double it and I have 46. So that takes care of all the segments, the sides that I'm looking at. Now let's go to angles. WXT is 35. ZWT is 59. That would be this part. We need to go through and solve. Oh, we've got one. WZY. The whole thing there is 72 degrees. So what I like to do on these is first go through and find all of the angles. Once I have all the angles, then I can find the parts that I need. So first off, we have alternate interior angles because of a parallelogram. So if this is 35, this portion down here, TZY, is also 35. So let's get rid of the 72. And write 35. Now we did know that that combined to be 72 degrees, so by using angle addition we have 37 degrees here. Using alternate interiors and the fact that the opposite angles are congruent, I also have a 37 up there. Now we can keep going. Alternate interiors give us a 59 down here. And I start to get two angles of a triangle. So 59 and 37, if I combine those together and subtract them from 180, I get 84 degrees for these two angles, also using vertical. I can then subtract that from 180, and I get 96, and I could say, well, 96 plus 35, subtract that from 180, and I get 49 degrees for these two. So now I have all the angles, I can go find what I need. TZY is going to be 35 degrees. XYZ, it's those two. So let's see, 49 and 59, I can combine that together to be 108. XWT is going to be 49. And XYT is going to be 59. So what we really use there is parallel line rules with alternate interiors, triangle sum, some angle addition, and vertical angles, linear pairs to actually find all the values that we're looking at. And that's something we'll commonly see whenever we are looking at parallelograms and having those diagonals drawn with all those angles. So the second part is now we need to prove that it's a parallelogram based on the information. So this is the list we had right here. So first reason on number 1, that's going to be that opposite sides are congruent. Now be careful not to say opposite sides are parallel. It's not marked as parallel, they're marked as congruent segments. Opposite sides congruent. Number 2, I have one set of opposite angles congruent, but that is not enough information. So that it's just not enough. We would need more information. We are not going to be able to prove that is a parallelogram. This one, number 3, I have one set of opposite sides are congruent and parallel. So that's the 5th reason we have right here. One pair of opposite sides congruent and parallel. We'd provide that reason. You can write that on your own. Number 4, this is diagonals bisect each other. Be careful not to say diagonals bisect. You have to indicate what they are bisecting. Diagonals bisect other diagonals. It forms midpoints for both. Number 5 is the better version of number 2. And number 5, both pairs of opposite angles are congruent, and that makes it a parallelogram. And last, number 6 is actually the definition of a parallelogram because two sets of opposite sides are parallel. So you could write those reasons in as you go. Now we're going to go through and solve some more. So first off, I have to find up here on the top left UT. UT is opposite of the 27, so opposite sides are congruent, 27. ST is opposite to RU, so that's going to be 18. VS is going to be 7 as well because VU is 7 and they bisect each other. Then VT, because I know that RT is 30, each of these portions are 15, and so I have 15 for VT. The top right, where I need to find the measure of angle R. I know angle R is the same as angle P, so if I can find X and substitute it back in to then find what angle P is, I can find angle R. So we'll make a note of that. The measure of angle P is equal to the measure of angle R. Now, these two angles, Q and P, are supplementary because they're next to each other. They're consecutive angles. So we're going to go 3x plus 5 plus 8x minus 12 equals 180. That's 11x minus 7 equals 180. 11x equals 187. If I do 187 divided by 11, we get 17. So now I need to find the measure of angle R, or angle P. So the measure of angle P is 3 times 17 plus 5. And that comes out to be 56 degrees. So that means the measure of angle R is also 56 degrees. For our next problem, we know that KLH is 134. So we have 134 here. Now, 25 at JHN is alternate interior, so this angle is also 25 at LKN. And what I'm looking at now is this sum of these two angles and the 134 are supplementary. So we're going to go 4x plus 9 plus 25 plus 134 equals 180. I'm going to combine all my terms on the right or the left side. I have 134, 25, and 9, which gives me 4x plus 168 equals 180. We get 4x equals 12 and x equals 3. For our next one, the measure of angle B, I have A and C. I know those angles are congruent to each other because they're opposite in a parallelogram. So how about I find those angles, and then I can find their supplement, or the angle next to them, and that'll give me angle B. So we're going to go 6x minus 15 equals 4x plus 11. If I subtract 4x over, I get 2x minus 15 equals 11. Then we get 2x equals 26 and x equals 13. Now I'm going to put 13 in for x here. So that's for angle A. So we are going to go 6 times 13 minus 15 gives us 63. So if the measure of angle A is 63 degrees, the measure of angle B is going to be 180 minus 63, and that comes out to be 117 degrees, which would also be the measure of angle D. Next, we have that NS is 2x plus 7. SQ is 5x minus 23. Diagonals bisect each other, so we can set those equal to one another. Subtract 2x, we get 3x minus 23 equals 7. 3x equals 30, and x equals 10. Now, they asked us to find NQ, which is the total length. A couple options we have. I could plug 10 in, or substitute 10 into both of them and combine them, or I could substitute and find one of them and then double it, because really they're equivalent. So let's just say that if NS is 2 times 10 plus 7, that gives me 27. NQ is twice that, so that would be 54 units. Last one is actually the same as the one on the middle left. We don't need to do that one again. We'll just call this one good.